Welcome to another episode of Improving's Virtual Lunch and Learn series. My name is John Kavanaugh Johnson, and today I'm going to share some basics of software architecture that I've learned over the last 25 years or so of building software. I hope you had a chance to see Michael Perry's talk last week. Michael takes a very mathy view of the world, and I lean a little bit more to the social sciences. However, I'm going to assume for the basis of this talk that you're designing your APIs with the ACID 2.0 principles that Michael talked about last week. So if you did get a chance to see his talk, after this one, you could go take a look at that one. We've got it up on YouTube. So the first thing I want to do is put a little context around the talk. So if you've been to one of my presentations before, you've probably seen the slide. Say not, I have found the truth, but rather I have found a truth. I think that's really important for folks in this business to remember. We tend to think in fairly binary terms, and software architecture is actually a pretty fuzzy topic. The other thing I want folks to remember is that all models are wrong, but some models are useful. George Box was a statistician, and he was talking about statistical models. I think this applies more broadly to all sorts of models. So everything I say today is going to be wrong. Well, at least it's going to be wrong in the sense it won't be a perfect fit for your situation. However, I think you will find it pretty useful as a way of thinking about software architecture. So a little bit of a prelude. If we're going to talk about software architecture, what's the point? Now, rather than ask what is software architecture, I'd like to try to answer a different sort of question, which is what purpose does software architecture serve? So if you want to ask why is software architecture, like why does it exist? If you go on the web, you'll probably see a picture that looks like this when people talk about software architecture if they want to illustrate a point. I find this a less useful way to model software architecture because I think it leaves out the most important parts. If that doesn't work, what does work? If it's not helpful, how do we make something a little more helpful when we think about this? Well, I'd like to focus on a quote from Colonel John Boyd, said people, process, technology in that order. John Boyd was an interesting fellow. He started as a fighter pilot in the Korean War. And after the war was over, he was given a job, which was to figure out why the U.S. won all of the jet fighter dogfights during the Korean War. That was not an obvious question to answer. According to the way the world looked at fighter planes at the time, the Russian planes were just as good as ours, maybe even better. What he ended up discovering was pretty interesting. It sounds really simple. It boiled down to this. U.S. fighter jets at the time used fly-by-wire. And what that meant was that the pilots could react more quickly. The plane would do what they wanted more quickly for the Americans than for their opponents. And that really changed everything for a dogfight because what it meant was the American pilots could actually envision things that weren't even possible. And one of the reasons that we're going to talk a little bit more about John Boyd as we go along is that the idea of creating your feedback loop so that you can react more quickly is sort of the core thing. He went from that simple task to a lifelong series of learning about how to win. And although I'm not going to be involved in any wars as far as I know, I do like to win. So if we're going to think about the people in software architecture, who is served by software architecture? Okay, the picture's just there for the folks who are fans of British TV comedy. But the important thing is that software architecture serves a lot of different roles. Obviously, developers, users, customers, product owners, product managers, product whatever, and then, and this will vary depending on what your situation is, but there will be other people, and ultimately software architecture serves humanity as part of the way we hope to progress as we move along. Now, um, there are a lot of trade-offs in software architecture, and there will be many times when, as a software architect, you have to make decisions about whose needs do I meet today with this aspect of it. Um, Developers need this, but the end users need this other thing that is in somewhat competition with that. However, it's been my experience that there's some qualities of software architecture that serve everyone, and that's what we're going to focus on today. So how well does it serve the folks who matter? So there's a saying that the proof of the pudding is in the eating, which means that the only way to really effectively judge this is with real world examples. Um, I want you to think of today's session as a sort of recipe. Like, you'll have to decide if it sounds like something you'd like to consume, and you'll probably want to try it out a few times as you design things. You might even find ways to improve it, and I'd love to hear from you if you do. And for those who are curious, that's a picture of Lucy Kavnar, who's my granddaughter, one of my granddaughters. Um, I do like to illustrate the things I'm talking about with real world examples, and who appreciates pudding better than a child? So the first of the 3 R's that I want to talk about today, responsive software architecture. Now, what do we mean by responsive? We're not talking about the size of the screens that you use. We want to design architecture that is responsive to the needs of the folks who matter, the folks that we just talked about. Now, when we think about this, we want to think about this in terms of the architecture itself, which means our architecture is not fixed in time. That is, it will evolve. Every project that I've worked on, the software architecture has evolved, whether we wanted it to or not. I found that it's more useful if we just go with the fact that our software architecture is going to evolve, and think about designing our architecture in such a way that we go with that flow. So if you want to build software architecture that's responsive, you need to allow the software to grow incrementally, adapting to the changing needs of the folks who matter and maintaining its fit for purpose. Now, those 3 things that I just talked about, incremental, adaptive, fit for purpose, those things are very much connected and build upon each other. By the way, if you're curious about that picture, so that thing in the picture there that you see, that's an experimental room made out of materials that adjust to the environment. As the temperature and the humidity change, the openings in the building, in the room, change to let in more or less air, so that it has been designed with the intent to adapt. And I think that's a good illustration in the physical world of something that can be a little hard to think about when we start, really trying to figure out how we're going to do things. Now, incremental software architecture. Now, you're going to guess that thing in the picture wasn't built incrementally. If you're not familiar with his work, that's a cartoonist named Rube Goldberg. And he was, really big on these sort of funny gag pictures of these overcomplicated machines. And I'll be honest, I've been on projects where the architecture reminded me a little bit of this. Now, the quote you see there, a complex system that works, is invariably found to have evolved from a simple system that works. That's from something called the Systems Bible by a fellow named John Gall. I have found that book to have more information about how to build good software than any software book I've ever read. It is much broader. It thinks of systems in much broader terms. But my experience has been that that statement is very much true. If you find a complex system that's working, and most of us go into an environment and there's already a working system, we may be replacing all or part of it. And it, to us as software architects, we go into that, or even as developers, you go in, you look at that, and you go, oh, this is a mess. This is the most messed up thing I've ever seen. How could it have gotten this way? But the truth is that those legacy systems evolve over time. And they didn't start out that way, right? And so if we remember this, we won't make the biggest mistake that I see projects make. And I've seen them make this for my entire career, which is saying, well, John, we can't do that. We can't start small because, and then there are any number of reasons, mostly because the idea of trying to build something new in the context of something old is fairly daunting. We'll get to how we do that in just a second. Now that first quote, the crucial variables are discovered by accident. This is also tends to be very much true. As you design your systems, you will discover almost by accident what really matters. What are the crucial variables that make the system? And I'm not talking about the software. I'm talking about the system that involves people and other organizations, or, you know, the internet, or whatever your system interacts with, right? The variables there are usually discovered by accident. And then the second quote, now, you probably didn't think Barbara Jordan was actually somebody who made a quote about software, and I don't think this quote was actually about software, but it applies very well. We do not reject our traditions, but we are willing to adapt to circumstances when change we must. We are willing to suffer the discomfort of change in order to achieve a better future. Now, I want you to think about that, because some of the things I'm going to recommend are going to cause some discomfort, and I'm aware of that. Change, as you build a system, changing your architecture always seems a little unnatural, and it seems a little too expensive, and all these other things. And the thing I'm going to tell you is that if you don't plan for it, it'll happen anyway. It'll be unplanned, and it'll always be worse. So if you can build your software architecture incrementally, and you can adapt as you deploy your software into production and get some feedback on it, then you have a chance of creating software architecture that's fit for the purpose, that solves the problems and the needs for the folks that matter. Now, I feel a little weird quoting myself here, but there are no technical decisions in the software architecture. There are only business decisions. Like software architects, if you get a group of them together, you know, we'll be talking about SOA versus event-driven architecture, microservices versus monoliths, whatever, X versus Y. That's the kind of conversations we have. If you go out on the web, you'll see that everywhere. I actually don't think any of those are the right conversations to have. Microservices versus monoliths, well, that depends on what your business users need. Now, it may be true that more often they need one thing than the other. Sometimes that choice will be driven by the needs of the developers on your team. But here's the thing. If we say something fits like a glove, we all sort of instinctively understand what that means. But I put this picture up here for a very important reason. The thing your software is doing is different from the thing my software is doing. You may need a catcher's mitt. I may need a work glove. We need to make sure that we keep our software fit for the purpose. I've seen a lot of projects go off the rails, quite honestly, by trying for some sort of technical purity. Technical purity is not wrong. It's not useful. It doesn't generally solve people's needs. So how are we going to do this? Like, let's get practical with some implementation. Okay, that doesn't look like practical software implementation advice to you. Let me talk about this. This is a little complicated, so I want to break it down. This is John Boyd's OODA loop, by the way. And in the context of software architecture, you can think of your cultural traditions as the system you're building. You're building that new system within the context of a particular business that has particular needs. No two businesses are exactly alike. Your genetic heritage, I think of that as the legacy systems. That's the stuff you were born with, right? You came into this thing and there were these systems that existed. By the way, if you're ever in an opportunity where you get to build something and it's a total clean slate, greenfield development, good for you. Somehow I don't get that chance very often. But if we're going to build responsive software architecture, we're going to have to meld new information. And the only way we can get new information for our software architecture is to actually deploy something. It's design, build, deploy, learn, repeat, make more stuff, right? I want to remind you that Barbara Jordan quote was, "We do not reject our traditions," right? We're not going to throw everything out, but we're going to be willing to adapt to new circumstances. The reason you're building something new is because somebody needs it, right? Somebody needs that thing you're building. And so as the circumstances change, we're going to have to change. So this sounds simple. Solving a problem is more useful than building a feature. If you're going to start with incremental software architecture, you want to start by solving a problem. The problem is not, we need to replace this entire system. No, the system's being replaced because it doesn't meet somebody's needs. What's the most valuable thing you can do? Make a list, pick out one that's easy, tackle that one. Tackle it with the understanding that you're going to solve that problem. And as you build features and solve more problems, the thing you did first is likely to change. When I talk to people about this, I get a lot of pushback because people are typically going to say, but we're going to build a bunch of stuff and then we're going to throw it away. It's like, I think to myself, but you already decided to throw away all this other stuff, but we're building this new. And it's like, yes, that's true. Your code is going to change over time. Your architecture is going to change over time. That's a good thing. So we'll talk about how to make that a good thing as we go along here. Now, let's get really practical. Here's the most effective way I found to build responsive architecture. Now, I'm not saying this is the only way. You may have a different way of doing it. That's great. If your software architecture is responsive, that's what's important. What I found is that I focus on the messages, the things that happen in between me and other systems, in between users and the software, in between elements of my software, in between my software and those external systems I have to deal with, all the stuff that's in between. The stuff that we tend to think of as just a collection of our object model or our database design or whatever, those are the things that actually matter. And focus on designing your message types. Your message types, what I found most useful, have immutable data. When you send a message, you sent that message. There's no way to change the fact that you sent a message and it had this data in it. If that data was wrong, you need to send a message correction saying, oops, I made a mistake. The shape of your messages can be dependent on the process. And what I mean by that is an order, when it gets, created, maybe by an end user who's a customer of your system, it doesn't have the same shape, the same requirements of an order that you're going to pass off to fulfillment, right? In between, things change. And so one of the ways to make your software architecture and your software responsive is to understand that it's not just what a thing is, It matters when the thing is. Where is it in the process? And this thing that I labeled a request, most software developers and architects call these commands. That seems a little, I don't know, eccentric to me. What you're doing is actually making a request of the system, right? You're requesting the system do something for you. And the system's going to do that, or it's going to not be able to do that, and it will come back and tell you why, what happened, that sort of thing. And then the other thing about your message is that they will frequently be business documents, orders, invoices, shipping manifest, whatever makes it's a payroll, it's a payment, whatever those things are for your business, those are often going to be messages. Now, as you build a system over time, right, the shape of a message, even in the context of one process, may change as new requirements come up. That's okay. Remember, we're going to suffer the discomfort of change in order to achieve a better future. And what you will find is that when you design a system this way, that you will have more changes to things like your object model and your database design than you will to the messages that represent your promises to the outside world. So we've talked about responsive system architecture. The next thing we're going to do is talk about resilient system architecture. So if we don't have any questions about the first part, we'll talk about resilience. So conditions change. Responsiveness in your architecture means evolving it as the climate changes, right? As the gradual things in the business change. Resilience is dealing with today's weather, right? If there was a hailstorm, your system needs to be prepared for that, right? So what we want to think about here in terms of resilience is, how does your system respond when bad things happen? So I primarily think about resilience in terms of two kinds of stress. There's, the internal stress. Everybody's probably seen a screen that looks like that. Your hardware can go bad. Your network might go down. There's all sorts of things that you may have issues with the way your system processes things. Those kinds of things, those internal stress and how your system handles it matter. And of course, the other kind of stress that you have to deal with is external stress. Maybe you get a spike in usage, or maybe there's a, denial of service attack against your website, or whatever it is. Sometimes the external stress is good. We have a whole bunch of orders. Sometimes the external stress is not so good. My business partner sent me that 4 gigabyte file and it's malformed, right? Those kinds of things, that happens in real life. And your system, your architecture needs to be designed to deal with that. And there's one particular strategy that I think works most effectively. I tend to call it a fire break. If you're familiar with the way people manage forests, you see that line running down the middle there? That's a fire break. What's the point of that? It's an investment for a difficult future, right? It's an acceptance that someday things might go really, really wrong. If you're growing a forest fire typically is not a good thing. So it's important to understand that resilient systems will cost you more in the short term. What you're trying to avoid is preventing the ripple effect, and it's usually very much worth it. If you've been around software systems very long, you're probably familiar with the ripple effect. You have an error somewhere over here, and it ripples all the way through your system. The way you deal with that is with fire breaks. So let's talk about how you build a fire break. So again, we're going to go back to Boyd's model, and this time, instead of focusing on the stuff that's inside the orientation loop, we're going to focus on the outside, the weather, right? So you have unfolding circumstances, things in the outside world that are affecting your goal for your system. You have the interactions that your system has with the environment, so the things you cause by doing things, right? And then you have the actions that you take. Now, when we think about this in terms of resilient software, we need to think about this in terms of how do we design a system so that it can survive these sort of stresses. The technique that I've seen used most effectively is called the actor model. Oh, not that kind of actor model, this kind of actor model. Here we go. Um, the actor model is fairly straightforward. It involves an address, a mailbox, and a function. So the address is how somebody sends you a message. The mailbox is where the messages go before your function can deal with them. Your function deals with them, and typically they will send out one or more other messages. Sometimes they just do things. Now, this whole idea was popularized way back when by a language called Erlang and OTP. And the core idea there, you can go look that up if you're interested in it, but the core idea is really, really straightforward. That is, you have your core software and it rarely has errors because you push the potential stressors to the edge of your system. All the edge stuff, that stuff that's outside your control, the stuff that can cause stress, right? The actors who deal with that are expendable. If they blow up, you just, spin up a new one. You want to break your actors into coordinators and doers. Coordinators, they coordinate, right? They say, oh, we've got a message here from the outside world. We're going to, oh, this is an order. We will send it off to an actor that does the first step in the order process, right? That coordinator may or may not, depending on how you design your system, track that order all the way through. There's lots and lots of implementations of this model. I've used one called Akka.net, which is an open source port of a Java framework called Akka. Had some good success with that, but there are tons of other ways you can implement this all on your own if you want to. If you're in an environment that somebody hasn't done this already, it's not that difficult. Fundamentally, the key here is not so much the implementation, but the idea that you think about where your problems can come from and you design your system so that you separate the stress, right? You create that fire break, the stress from the central part of your system that keeps your application running. So we've talked about resilience and responsive. Now I want to talk about retrospective software. Now, retrospective seems a little bit of an odd word to use about software architecture, but the important thing here is if your software architecture is going to be responsive and resilient, the best way to do that is to know what happened, to have a sense of the past. So, before we start on that, I think we got a question.
I have a question, John. You suggest focusing on solving one immediate problem after another, but what about higher level decision and design? Is this not a recipe for designing Rube Goldberg machines?
So that's actually a really good question. The idea of solving the problem shouldn't take away from your overall design. When I approach software architecture, I always have a pretty good idea of what the overall design and the high order problems are. What I know is that I don't know everything. That is, I will discover crucial things that I don't know yet. And the only way I can discover that is by having software in production. That doesn't seem like it should always have to be true, but in my experience, it has always been true that you have your plan, you have your big picture software architecture, you need to deploy something that fits in the plan somehow, that solves a problem. Take that feedback and see if you need to adjust your bigger plan. The point here is not to avoid making the bigger plan. The point here is to don't cast things in stone before you have to. One of the phrases I ran across a few years ago is the last responsible moment. Put off your decisions until the last responsible moment, because you have an opportunity until that point to get more information. Now, the truth of the matter is that there always comes a point where we have to make decisions in the face of uncertainty. And that's going to be where, that's where you earn your money. It's where you make those decisions and move forward with those things. So I think I got that one. So let's talk about retrospective software architecture. Fundamentally, every system I've been associated with as a developer or a software architect or somebody who's come in to try to fix some things that were broken, because I've done that too, the question we needed to answer was, why is this happening? And it is often the hardest question in software. Because to know why, you have to know what's happening. You have to know who caused it, when did it happen, because you may have a problem, but the actual, the thing that caused it happened way in the past. Now, way in the past may be a few milliseconds, or it may be months ago. But you need to know when it happened. You need to know where, and by where I mean sort of logically, where in your system did it happen, and then how did it happen? How did this unanticipated thing happen that you weren't prepared for? Now, there is a very common answer to this problem. It is not the answer that I choose. I do not choose logging. Now, that's not to say that logging is wrong. I have found logging not to be as useful as it could be. You may or may not be able to read all that. It doesn't matter, because it doesn't really tell you anything. This is a giant stack trace of things that went wrong. Doesn't tell me much about what caused it. Now, if I want to know what happened and why it happened, how am I going to be able to do that? How do I answer all those questions? The other thing about logs is, in my experience, they are often ignored until it's too late. The more you log, the harder it is for anybody to keep up with it. I think that's experience a lot of us have had. So we're going to go back to Boyd's questions here, his OODA loop. And you'll notice that all I've got highlighted there is previous experience. If your system doesn't have a way of incorporating previous experience into the architecture, it's not going to be able to answer these questions very well. Now, you may be able to figure it out from other logs. You've got your system logs. There's all sorts of information. And when the application doesn't do an effective job of logging, I've been in environments where I had to dig through network traces and all sorts of horrifying sort of things to figure out what the previous experience was. But there's just one simple technique that addresses this very effectively that I know. So there may be others, but the one that's worked for me is to record my messages and outcomes. Now, instead of a log, what you have is a business record, right? Your messages are things that the people who matter think matter, right? They think that those things matter. Most business people, they're really interested in orders and invoices and payments and payments sent, payments received, all that stuff around money and maybe for some organizations it's client satisfaction, but all of the information your system has, if you've designed your system the way I've been talking about, that's going to be in your messages and that's going to be in your outcomes. And this can become very central to the business. I've been in environments where we've been able to do this, and then the people who were most interested were analysts, and then sometimes it's the business intelligence folks, and everybody goes, look at all this stuff we can look at now. We can do more than just count how many orders we had this week. We can count how many orders were actually successfully fulfilled. We can count how many orders generated errors because they lacked sufficient data or whatever, right? All of these things become real information, not just data, but information for the users of your system to manage their work. And this is the thing that I think has real power here. We want to think about these things in terms of don't create data for the system. Don't create data for the administrators. The administrators are nice people, don't get me wrong. They'll be able to use this information too. But the target for this sort of record are the users, the customers, the people who interact. Sometimes you'll discover, and I've seen this happen, is when you take this approach, you will have your company's business partners coming to you so that you can tell them about what's going on in their business. And boy, that tends to make the business users in your company really happy when that happens. I'm not sure why, but that's the thing they like. So let's put this all together. We'll have some time for questions here at the end. So if you want to approach this, the way I'm going to suggest you do it is solve a problem. Solve a problem. When you find out that that problem is solved, go to the next problem. Do this within the context of your overall architecture, your whole approach to building the new system. The new system, we'll take that as a little bit of a fuzzy complex, but what you're trying to do is your company is there, they want new software, build it in a way that's most useful, right? Design your messages. Really think about the information that's transferred from one person to the system, between systems, between components in your system. It's the stuff between, the messages that go back and forth. The nice thing about messaging is it actually solves a bunch of those. Remember I talked about the whole, we software architects like to talk about this versus that. So one of the big ones is, synchronous versus asynchronous. And the thing I like about designing message-oriented systems is you get to choose and you can change your mind, and it's not that hard. With the more traditional RPC approach, that can be a very difficult thing to do. Lots of good frameworks to support that sort of thing. I really like the explicitness of deciding when a consumer needs to wait for the answer. Because again, that's not a technical decision. That's a business decision. Does the customer want to wait to find out if their order was accepted? You might be surprised to learn that the answer to that question varies depending on what kind of system you're building. There's lots of places where customers are more than happy to say, here's my order. Tell me later if you actually were able to fulfill it. There are other environments where it's like, no, I need to know now. Are you going to be able to fulfill that order? In general, what you end up with is a lot of people want to know that your order was accepted. That doesn't mean that the message got there. It means that the message got there and we looked at it and said, yes, that works. We can do that, right? Sometimes, you may need to find out if you've got inventory to answer that order. All of these things are business decisions about synchronicity. Design your systems and your architecture so that that's a question that your users and customers can answer. And then finally, just record those events. Record what happens. Not just for figuring out why the problem happened. That's kind of the why we do it, right? But the side benefit becomes the thing that really is amazing, which is that suddenly you have information about your system that nobody ever had before. And I've seen that turn out to be very powerful. Now, before we go to the questions, I have one other thing to wrap up here. So I like to tell people, please do as I request, only if you can do so with the joy of a little child feeding a hungry duck. Not everybody knows what it looks like to see a little child feed a hungry duck, but there you go. You got to see it. By the way, that's my other granddaughter. That's Amara Potter. So think about whether this makes sense to you. Think about whether you want to try this recipe. And if it would bring you joy to try this recipe, try to apply some of these on your next software effort. Now, we're going to have some time for questions. And I do want to alert everybody to a really great talk that's coming up on Friday, which, by the way, I know you think I have to say it's a really great talk, but no, this is Craig's thoughts. This is going to be good. It's going to be called Shifting Application Security Left. So not quite sure what that means, but come on Friday. No, there's a whole blurb where Craig explains what that is, and you go look on the website. Okay, Michael, do we have any questions? I think Michael is saying that there's no questions he can actually say out loud. No.
Here's a question that came in, John. You mentioned that in messaging you can choose between synchronous and asynchronous options. Could you dive into that just a little bit?
Sure. So one technique that I've used is if you use an actor model where everybody's sending messages to a mailbox. So let's see, we'll go with the I've placed an order and I need to know if there's things in stock that will be used to fulfill my order. I have ordered 37 widgets. Before we accept the order, our understanding with our customer is that we will check to make sure we have 37 widgets in the warehouse closest to that customer. So we fire off a message to the inventory system. Now, the customer's fired off a message, right? Now, the actor that's interacting with the customer is going to need to receive a message back that's a confirmation. And that actor won't do anything until the message to the inventory system goes off. And eventually a message comes back with a correlation ID that says, oh, the order for this customer for 37 widgets can be fulfilled. And so you can accept the order. And so that message goes back. So that's all asynchronous, but from the perspective of the customer, it's a synchronous process. The customer's there waiting until they get the answer back. Now, what about time? This does not solve all the problems with asynchronous communication. What it does do is give you an easy way to layer a synchronous view on top of what is ultimately at the bottom. Everything in the world is asynchronous. It's just the reality of the way the universe works. Things are actually asynchronous. I hope that answered the question. I do have some more information. If you happen to be a baby architect, okay, that was just an excuse. That's Cooper Kavanaugh Johnson. That's my newest grandchild. So anyway, no. Here are some resources I really recommend. Go watch Michael Perry's talk on Aspen 2.0. That's the link to the YouTube video of his talk. Go read John Boyd's The Essence of Winning and Losing. After you read that, you're probably going to want to go read a whole bunch of other things. But Boyd discovered a model that's very effective. I actually use it for thinking about the way teams work and the way software works, which is an interesting way of sort of having one view of different things. And then the last thing, I highly recommend you read John Gall's The Systems Bible. There's a link to the Kindle version, which is a lot cheaper than the paperback for whatever reason. Okay, so do we have any more questions? Okay, I think we're done. I really appreciate everybody who attended and stayed around, and I hope you will attend Craig's talk on this coming Friday. Thanks.